A very good morning, sir. In this vlog, I'm gonna show my simulation for Lab E1 Part 1 and also Part 4. So starting from Part 1, for Circuit 1, this is the schematic diagram that I came up. A and B are the input, while X is the output. So from this truth table, you can see only when both of the inputs are 0, it will produce an output of 0. If either one is 1, it will produce an output of 1. Now I'm gonna show the coding that I came out using Xilinx. So in this circuit 1, I've created 2 NOR gates. And when I simulate this model and expand this, you can see when 2 inputs are 0, it will produce an output of 0. And if either one is 1, it will produce an output of 1. So now I'm going to show the simulation of Circuit 2 of Lab E1 Part 1. As you can see from the schematic diagram, I used 2 NOR gates and 3 NAND gates. So for the ceilings, I write the code for 2 NOR gates and 3 NAND gates. As you can see, there are 2 inputs, input A and input B, which will produce an output of Y. When both the inputs is 0, the output will be 0, and when either one of the input is 1, the output will be 1, and when both of the input is 1, the output will be 0. So now I will show you the simulation of the Circuit 2. So when I expand this thing, as you can see, when both of the input is 0, the output will give a 0. When either one of the input is 1, the output will be 1. And when both of the input is 1, it will produce an output of 0. And that's all for the simulation of Circuit 2. So now we come to Part 4 of Lab E1. So in order to solve the question in Part 4, I've created a schematic diagram. In this schematic diagram, it used 3 NAND gate with 2 input and 1 NAND gate with 3 inputs. And this is the truth table of the schematic diagram. As you can see, A, B, and C are the inputs, whereas M is the output. So whenever there are 2 or more inputs that is 1, it will create an output of 1. So for example, if the input is 0, 1, 1, it will create an output of 1. But if the input is 1, 0, 0, it will create an output of 0. So now I will show you the coding that I've created using Xilinx. So in my coding, I've created 1 NAND gate, 3 NAND gates 3 NAND gates with 2 inputs, input A and input B, and also 1 NAND gate with 3 inputs, input A, B, and C. And here is the possible inputs of the whole circuit. Now I'll run the simulate behavioral model and show you whether or not my coding agrees with the truth table. And when I expand this, as you can see, yes, it agrees with the truth table. Whenever the inputs are 0, the output will be 0. When there are only 1 input is 1, they will produce an output of 0. But when the input is 1 and 1, it will produce an output of 1. Similar goes to the rest of it. And that's all for my presentation in Lab E1. Thank you for watching.